Hello there, it's Alana Tuckey, and this is going to be the lecture videos for our last section of Chapter 7, 7.8, Modeling with Quadratic Functions. So now that we've spent some time reminding ourselves of all the different kinds of regressions we know, now we're going to actually be asking ourselves questions about quadratic regression in particular. So we have let f of t be the number of deaths of motorcyclists in accidents in thousands in the U.S. at t years since 1980. And yes, this is real data. I got it from the U.S. government website. All right, so here are the years, and here are the motorcycle deaths. There they are. There's a lovely scattergram. So when you look at that scattergram, which was made in Excel, which is the best model? And you will have to learn how to make a scattergram like that as well for one of your projects, right? Don't worry, it's not too hard to do. All right, so it's a quadratic model is best because the data points form a parabola shape. Right? They go down and back up. If I could spell the word then. There you go. Good, done with that. All right, so now we're going to find it with our calculator. Of course we are. All right, so what's our starter year? It's 1980. Okay, so let's grab the calculator. Let's go to Stat, Edit, clear out the old, clear. And then our first year was 5. Let's see what else we got. 5. Oh, rats. There we go. 10, 15, 20. All right, get those in there. Then go to the right. I think I have all those perfect. Let's see. There we go. All right, so now we said it was quadratic, so let's hit Calc. You want number 5, quadratic regression. There it is. L1, L2, and just for the fun of it, let's store it. Variables, y variables, number 1, number 1. I think we'll actually need it for later on in the problem anyway, so it's probably a good idea. All right, so there it ran the quadratic regression. So let me grab that real quick and then go type it up. So the quadratic regression model would be, what was this? Was it Q of t? F of t. F of t is our model. Okay, so f of t equals 0.019 t squared minus 0.603 t plus 7.142. Hopefully it wanted 3 decimal places. Oh, it wanted 2. Oh, okay, I'll go even less. 60 and 14. There you go. Okay, there's our regression equation model. Oh, it wants r squared, so I better leave this in here for just a second. All right, r squared is approximately 0.976. There we go. I don't need that picture anymore. That was just for my own benefit. All right, so there we go. We have our quadratic regression model right here. And we have our lovely r squared value. Let me just make this approximation because it is. There we go. So how can we verify that the model we found fits the data well? Well, you can make a scattergram. Right? So make a scatter plot. Make a scatter plot of the data and the model and verify that the curve comes close-ish to all the points, right? It's not going to be perfect. That's not this kind of problem, but we want it to come moderately close to all the points. All right, well, luckily for us, we stored the regression equation. So if we go to the calculator, we go to y equals, see, there's the regression equation. It stored it right up there, 0.019 x squared and so on. And if your plot 1 is not dark, move up with your up arrow and press enter to turn it dark. Mine is already dark, so it's going to graph my plot 1 and my equation. But to make a good window, I need to hit zoom 9. See at the very bottom, zoom 9, zoom stat. So that's what you need to grab. So I'm going to hit 9, and it'll make a beautiful window. There's the scatter plot, and there's the curve. And now you'll draw a sketch of that on your paper. I have the advantage because I can just copy and paste right from my computer screen. But you would have to draw a picture that looks like that. All right, we're done with that portion. Now what? Now we need to find f of 25 and explain what it means. And there are our favorite words again, interpolation or extrapolation. All right, f of 25. So let me grab this. So if I want f of 25, what I want is to know what 0.02 times 25 squared minus 0.60 times 25 plus that. Okay. All right, so we'll grab a calculator and have it do that for us. So let me go quit out of here. Actually, there's another way we can do this, but I'll show you that in a second. So right now I'm just going to type 0.0225 squared minus 0.60 times 25 plus 7.14. Enter. So around 4.64 or so. Now there's another way that's a bit more accurate. If you go to the table, second table, remember we have the regression equation stored in y1, so if you just scroll down to 25, it's going to take you a minute to get there. Then you'll be able to see what the value is. And that's with more decimal places of accuracy than we've kept. Oops, there it went, it scrolled by. It's 4.2271. Hold on, right there. See? 4.227. So whichever the one you like. And we said before when we did it by hand, I think it was 4.64 when the calculator did it. So when we did it without those decimal places of accuracy, yeah, 4.64, you say, or 4.227 from table. Right? Which is actually a bit more accurate, honestly. All right, now what does it mean? And is that interpolation or extrapolation? Okay, well, let's see. This is the motorcycle deaths, right? So motorcycle deaths in 2005, right? Because take 1980 plus 25 and you're going to get 2005. So in 2005, there were approximately 4.227 thousand motorcycle deaths. Or 4.64, whichever one you want to use in the US, right? If you want to say 4.64 or 4.227, whichever one makes you happy. And that is interpolation for sure, right? Because it's amongst the data that you already have. Remember, if you're working within the data points you have, which you are, because 2005 is in between these two, that's interpolation. Extrapolation is if you went past 2008. If you talked about 2010, for example, that would be extrapolation. All right, next, find t when f of t equals 8 by calculator. What does that mean? All right, so let's go to y equals. And I don't need the scatter plot anymore, so I'm going to turn it off. So I've got that off. I'm going to go down here and I want to type 8 because I want to know when f of t, when this function is equal to 8. Let's press graph and see what it does. Okay, well, it's graphing it, but it's not on the screen. So let's look at our window for a second. Oh, we're in trouble. All right, look here. See that y max? Y max only goes to 5, but we just said we wanted to see 8. So how about we type in like 10 here just to see. And while I'm on the subject, why don't I make this 0 just for fun? So that way I can see my axes here. All right, so there's my parabola. Oh, and there's 10. Okay. Or excuse me, there's 8. All right, so let's go back to the window. We need to see some more. So for one thing, I want my y scale to be like 1. That way it goes 1, 2, 3, 4, 5, 6, and so on. And then x min I need a lot lower than I've got. How about negative 20 to 50? Let's just see. I don't know for sure if this is going to work. And then I'm going to pick 10 to be my scale. Let's graph it now. Okay, there's the parabola. We were only looking at like this lower chunk of it before. And there it is. Look at that. It comes right across. Beautiful. Right? So I just kind of guessed. I actually went a little too far over here, but that's okay. All right, then you hit second calc. Number 5, you want intersect. Enter, enter, and it's going to find whichever one it's closest to for the guess. So if you want to find the one on the left, move your little cursor over here to the left. So as long as it's closer to the one on the left and press enter, it'll find the one on the left. All right, so let me copy that. And then I want to find the other one. So I'm going to hit second calc, number 5. First curve, yep, the y1's my first curve. Second curve is the red one, yep, enter. Guess, I'm going to move my arrow. I need that cursor to move all the way over so it's closer to the one on the right. And I press enter. And there it is. There, I found both of them. Okay, so let me go put those in. Okay, now I'm drawing both pictures here because it's easier for me with my computer. You can just put them all on one parabola and just label the 2 points. There's the one on the left, which is negative 1.36, and the one on the right, which is 32. So now what does it mean? It means there was or will be, let me put this, were 8,000 motorcycle deaths in the US in what years? All right, so your starter year is 1980, right? So if you take 1980 and you subtract 1.36, let's go do that. So quit. 1980, subtract 1.36, enter. You get 1978. Let's find the other one while we're at it. 1980 plus, what was the other one? 32.35. 32.35 will get us 2012. So in 1978 and 2012. That's my YouTube channel. 1978 and 2012. So it was correct to use past tense here. There we go. Again, you don't have to draw both pictures to make this work. But notice one thing I did, and you might be wondering, how did I know it? And the answer is I didn't. When you fiddle around with your window, you're messing around with it to try to get to see what you need. I knew I needed to see higher than 8, so I went 0 to 10. That way I knew I'd get to see 8 because the second equation right here is 8 right there. So I knew I needed to see 0 to 10, and then I just guessed for x min and x max. I could have picked different values, like negative 10 and 40 would have worked as well, right? And that would have also sufficed, right? You just have to make it so that it's a nice looking picture that shows both intersection points on the screen. And then I fiddled with the scale just because I got annoyed by having so many little gray lines in there. So that'd be nice to go up by tens and so on. Okay, so now for the last bit, we're supposed to find the vertex of the model by our calculator. So let's grab the calculator, go to calc, and if you think about our vertex, it's going to be a minimum, so hit number 3, minimum. Now you need to move the cursor to the left of that minimum, press enter. Move the cursor over to the right of that minimum. Anywhere to the right will do, press enter, and you can just press enter, and it finds it right there. Now we've got to draw a picture and explain what it means. I got to type that up 1 second. There we go. It means that in 1995, because 15 plus 1980 would be 1995, there was the smallest number of motorcycle deaths in the U.S. at only 2.47 thousand. Make sure you comment that it's the smallest number because it was a minimum here. Of course, if it was a parabola facing the other direction, you'd say it was the highest number. All right, we're all done with this problem. I'll see you back here for the next one.